All right, next up, let's take a look at some predefined void functions. We're really interested in just how functions work. Not really interested in the exact functions. We'll talk about these things as we use them. So in this case, we're looking at just functions that do not return anything. So these things perform an action but send no answer back, that is, no return value. And so as a result, when it's called, it's a statement itself that doesn't have to be assigned. The value of this doesn't have to be assigned to anything because there doesn't have any return value. So no return value, not assigned to a variable. And so you can't do that. It'll probably generate an error. I actually haven't checked that. But that's what I would guess, is if you say x equals exit, you would get some kind of error message from the compiler. This particular function, all it's supposed to do is terminate the program. And so when in this particular situation, since it's going to terminate, it's not going to return anything, so it's no point in returning anything. Although it is technically possible that the call to exit might fail for whatever reason, you're not able to terminate. Potentially that is possible, but yeah, it doesn't make sense to return anything. Functions that do not return anything can still take arguments, and so those things are not related really. So it is possible to have a void function without any arguments or with arguments, either way. So all aspects are the same as functions that return a value, just that they don't just happen to not return a value. Void functions don't return anything. The random number generator works in a way that's somewhat similar to the math.random function and other Java util.random class functions that we have used, or methods that we have used in Java. So this is extremely useful. Returns a randomly chosen number used in simulations and games, things like that. So there's a couple of ways to use it. The basic function is rand with no arguments and returns a value between 0 and rand max. And I actually haven't checked to see what rand max is, so let's just do that. And we'll find out which library we need. So let's get rid of this and say int x is equal to rand, and let's just see what we get. Alright, that's a good simple test. Oh, I have to compile it. Oh, that's the wrong one, so I have to use I set up a makefile. And so I have to do something slightly different from probably what you are doing. Let me see if I can run this. Yes. Okay. So let's run this a few times and see if we get something different each time. Nope, we get the same thing each time. Alright, that's good to know. So if we don't seed the random number generator, we get the same set of random numbers. So if we use another call to rand, we can say x is x, copy, paste it, and we'll print out y. Save it. I have to compile this special way. Oh, you don't have to do that. Let's run this a few times. And what you should see is that we get the same sequence of numbers. If you did this many times, you should see the same sequence. I just want to quickly check the size of this. This is alright, so that is not quite a billion yet. It's a little bit less than well, it's a quarter of a million. I'm sorry, a quarter of a billion. So we can't really tell exactly what type it is, but I'm guessing this is either an int or a long. can't really tell from here. Okay, so what would happen if we said float? F-L-O-A-T. Let's see what happens. Compile this. Worked. And then we run it. And we get basically the same thing. It's just expressed in a different format is all. Okay. Good. So everything works, and now we have to find out, well, what exactly is this randomX? So oftentimes when you get when you use a random number generator, in the case of Java, the math.random function always returns a value between 0 and 1, and then we can scale that out. That's typically what we do. However, in C++, we have to scale, often we have to scale down because we get a massive number. Like, for example, the last two numbers we saw was 16,000 and then 200 and some million, which is big numbers. And so one way to squeeze this into a smaller range is to use the mod operator. So let's take a look at that. So if you want to choose, for example, let's say we have two random number generators and we want to choose, we have two calls to the random number generator and we want to use, let's say, these values as indices into an array, and we're not going to set up the array, we're just going to assume that it's there. But the thing is, if the array is of size, let's say 20, what do? These random number generators, as we saw, will give us massive numbers. Oops, sorry, didn't compile, forgot to compile. Okay, there it goes. Compiled and gives us massive numbers. So let's say we have an array of size 20. So we want numbers to be between 0 and 19. What do? We say we want something mod 20. Something mod 20. And now, got to compile it. Okay. We still get random numbers, but we get numbers that go between 0 and 19 in this case, if we mod it with 20. So we are still, these calls to rand are still generating the same old numbers we had before, 16,000 something and 200 and some million, but we're modding them to by 20 to get numbers between 0 and 19. We'll always get the same numbers, so it's predictable. You get the same sequence of numbers. So if you had 3 numbers, x, y, and z, rand would always give you the same set of 3 numbers. And of course, if you mod them by 20, you still get a predictable set of numbers. Okay, so sometimes that's useful. Sometimes you want something truly random, and so that's when you use the seed function. And we'll look at that next. But before that, let's say you don't want to start at 0. You want to go between 1 and 6. Then you add 1 to the this. So for example, let's say we wanted to go between 1 and 20. What you would do is still mod by 20, and then you would add 1 to it. So if you do this, you will definitely always have something more than 1, right? Because you're adding 1 plus something between 0 and 19. So eventually, so the end result is that you will get a number between 1 and 20, including 20. Okay, so in this case, I don't think it'll change from 7 to 8 and 9 to 10. Not much different. So compile this and run it, and we'll get 8 and 10. It's very predictable. For a random number generator, that's actually what you want sometimes. You want to get the same sequence of random numbers. Okay, so these are actually pseudo-random numbers. That is, when you call rand, let's say 100 million times, right? You get the same sequence of random numbers. And we just looked at 2 numbers, but we can do that with 3, 4, 5, up to 100 million. You can set up, it's not hard to do, set up an array of size 100 million, call rand 100 million times. You'll get the same sequence every time you run the program. So what do you do if you want something truly random? Actually, it turns out you can never get anything truly random, but you can get something close by using a seed value. So you use srand to seed the random number generator and pass in the seed value. Now, if you always pass in the same seed value, you'll get the same numbers each time. So it's not srand itself that gives you true randomness. So let's try it out. srand, and let's just say 105, something like that. Okay, so now we'll get different numbers, but the thing is, if you're using a constant value here as the seed, you will still get the same sequence of numbers after that. Okay, this compiled. Let's run it. Okay, these numbers are different. Now we got 16 and 15. But then if you run it many times, we still get the same sequence of numbers. If we run it and call rand 100 million times, we'll get the same sequence. So what do we do? Well, what we do is we want to change the number that you put in here somehow. And common ways of doing that are, for example, to use the time. You use the current time and convert it to an integer, pass that into srand, and then it's a little bit more random, but if you happen to run the program at the same time of day, for example, you will get the same sequence. So it's still not truly random. You can get it close to random by seeding it properly, seeding it with something that's a little bit more unpredictable. Okay. So you can use the time predefined function to return the system time as a numerical value. You have to #include time, and then you're pretty much set. You can use srand time with the value 0, which is basically means time now, and then you get a much more random value. So you won't get predictable things if you run it a couple of times. Okay, so we looked at all of this. We can get a random int between any set of any range, like between 1 and 6, between 10 and 20, by using the appropriate values for the mod and the additional shift factor. Alright, so I'm hoping that's all straightforward. Next, let's take a look at programmer-defined functions. That is, how do you set up your own functions?